Well, hi there, everybody. Welcome to Dome at Home. Glad you could join us. My name is Scott Young. I'm the planetarium astronomer at the Manitoba Museum, and I'm really glad to see you here today. It's really fun to run these shows, so I'm pretty excited to get to do another one here. All right. For those of you that have been to our programs before, you kind of know the drill. This is all about things that you can see in the sky. The program is sponsored by the province of Manitoba's Safe at Home program. The idea being you can be safe at home and go out into your backyard or look out your window and see things in the sky and do things with the people that you're at home with. So this gives you something to do during the time while we're still taking some time at home. All right, with me as always is my colleague and friend Mike. Mike, how you doing today?
I'm doing good, but Scott, I got to let you know we can't see you right now. We just see your opening screen there, but we don't see you and your lovely face. Ah, there
That
you
is
are.
hilarious. Well, thank you very much. That was a little unusual, but
That's all right.
yeah, I think.
Well, we'd all like to see you for for the show, but yeah, I'm doing good. I'm a happy man with lots of Mars stuff coming down. I love learning about Mars. So what a great week it's been for all the amazing Mars stuff that's come out. So I'm just happy as a clam.
Oh, absolutely. The Mars stuff that came out just this week is kind of stunning, and that's actually where we're going to be starting our program in just a couple of minutes with some of the latest stuff from the Mars Perseverance rover. We had some letters that came in between this show and the last show, some emails, some messages and things like that. I did want to say hi to Daniel from Oakenwald School in Winnipeg and Ms. Mitchell's class, grade 6M. Thanks for watching. Their teacher takes our Dome at Home programs and uses them in her teaching and things like that, which is really nice to hear. I also wanted to say, oh yeah, there we go, 6M gang. I see Ryan later in the comments there. That's the group. Yeah. I wanted to wish a happy belated birthday to my friend Rowan, who turned 4 on Monday. I just got an email from Rowan and her mom Melissa just a day or so ago. And she sent me this great picture of Rowan being curious, exploring the planet that she lives on, exploring Earth. And it was just amazing to see people taking to heart the idea that this isn't something you watch, this is something you do by going outside and exploring, whether it's exploring in the daytime or exploring at nighttime. And that's kind of the whole point of this show. So it was really great to hear from you, Melissa and Rowan. Happy birthday. And they're out in BC, but their grandparents are here in Winnipeg, and so it's kind of a nice way for them to share some content and do some things together. So that's always really nice to see families being brought together by our program here. Let's see. We also have we have been getting some pictures and some videos of your Mars lander activities. I got some video from Amy where she put together her Mars lander with the egg inside and threw it out the window. It looked really cool. We're going to be showing that video on a later episode when we've got a few more of them in. And so that'll be coming up in a future episode. But I did get yours, Amy. Great job. And we'll see yours fairly soon. So Mars Perseverance. We saw the great landing last week. We only had a few pictures though, because there it was all the data to make sure that the thing was safe. Well, now the pictures have come back. And on Tuesday, they had this amazing press conference where they showed us video that we had never seen before. They actually stuck a bunch of video cameras on the lander and it took full high def video all the way down. It looked like a drone footage kind of thing. And if you didn't see that, we're just gonna watch it here because it's just too amazing not to watch. So the voiceover is from Mission Control, and then the images are coming from the video that was recorded during landing and then broadcast back to Earth, not live, but sort of after the fact. So let's join Mission Control
straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deployed.
The navigation has confirmed that the parachute has deployed and we are seeing significant...
You'll remember we talked about the parachutes being tested by Black Brant rockets that are made here in Manitoba. It's kind of nice to see that they all worked really well. I guess the tests worked.
Heat shield SEP.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
LVS valid.
We have confirmation that the lander vision system has produced a valid.
This is just incredible footage. I mean, parachuting down above the surface of Mars here, you can actually see the craters that we're supposed to be landing next to. And any minute now, things start to change really rapidly. So right now it's floating around, blowing in the wind. Now the parachute's gone and it's under rockets. And you just see how much more steady the view is because the rockets are correcting for everything. They actually have to move a little bit off to the side so that the parachute doesn't accidentally come down and land on the lander. So they move off to the side here a little bit. And then it's right down to the ground.
Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO. Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sand.
And the cheering, yeah, I've watched it probably 24 times already, and it is fantastic. And you can see the excitement from the scientists there, but it was just so cool. Daryl just pointed out, yeah, I think it was on Nova. There was a documentary on the building of Mars Perseverance rover, just came on TV a couple of days ago. And he's dropped a link into the chat. Maybe Mike, you can take a look at that and see if we can get that out for everybody. But yeah, it's really a cool story. And there's some Canadian connections. There are Canadian scientists working on the Mars program. There's a company from Minnesota that has some of their camera control stuff on Mars. I mean, there's something from Minnesota on Mars now. That's amazing. You know, you don't have to go to NASA or anything like that. You can be part of the space program wherever you are. You just need to be the right level of interest and the right level of excitement and enthusiasm, and get your education and go from there. Okay, we do have some other images that have come up from our Martian probe. I have to start with one that's a little bit of a downer though. This one. So the Mars spacecraft, they take all of the images and they dump them directly to the internet. They don't go to the scientists first. They get literally put into the raw image folder on the NASA website, and anybody that wants can go and take them, and they're all black and white and they need calibration. But if you know how to do that kind of stuff, you could basically make your own images, which is great. But the problem is one person decided to make their own image and then put in a version of the sky as seen from Earth to sort of fill in the sky, because NASA doesn't take a lot of pictures of the sky. I mean, it's blank. There's nothing really interesting going on in Mars during the daytime. So he filled in this stuff and unfortunately didn't put a disclaimer. So the Mars Panorama is real, but all the stars and stuff like that people were getting excited about were not, unfortunately, real, which is quite a disappointment. I wish that this kind of thing didn't happen, in terms of, people seeing something and then having to have it walked back because it wasn't genuine. But that's okay. The stuff that is coming from Mars is pretty impressive. This is the first panorama that came. There you can see the spacecraft in the front. Off in the distance there, you can see some of the craters. This is the rim of the crater that we saw from the view down, and there's like a little cliff in front of it and so on. This is a massive picture. This is like, here, if we zoom in, it's so much bigger that I actually couldn't load it into my editing program because it's too large of a file at full resolution. So really amazing stuff that you can see. And they've got all sorts of zoom ins. This is the Z-mast camera that has a big zoom lens on it. So you can see individual rocks. This one they think has been sculpted by the winds. So the sand being blown around has sculpted it into all sorts of weird shapes. The pictures that are coming back are just kind of incredible. Hey, someone says they know the guy that made the cams in Minnedosa. Hey, let's chat. Let's chat, because I would love to talk to those folks and maybe have a little chat with them, because that's pretty amazing. Lucy's asked, has Perseverance collected any samples yet? No, not yet. Basically, it's still in the, we've landed. Let's make sure everything works. Let's make sure all the cameras are there. Let's take some quick pictures and stuff like that, so that we have a level of baseline. And then there's so many experiments. It's like, which ones do you do first? Do you drill into the rocks, or do you take the pictures, or do you fly the helicopter? I mean, there's all this stuff going on. So we'll have to wait a little bit for all of the things that are coming. From orbit, the Mars Reconnaissance Orbiter has taken this picture, and it actually shows all the pieces that we saw on the surface of Mars. The Perseverance rover, I'll show you a close up in a minute, but it's basically this little spot down here. The descent stage, that was the part with the rockets, is mostly just a dark mark on the ground. It probably exploded when it hit the ground. The parachute and the back shell, that's like the lid of the spacecraft, landed way over there. And then the heat shield that dropped off, the first thing that we saw after the parachutes, landed over here. So they've actually found all the pieces of the spacecraft. So here's the close-up. There's Percy, short for Perseverance. And you can actually see, the jets were pushing all the dust out to the sides. You can see that disturbed dust on both sides of it there. That's what that is. And in fact, if I just go back to our panoramic view here for a minute, there's those lighter dust areas, one there and one there. This is a 360-degree view, so of course it wraps all the way around. So basically this and this are on opposite sides of the rover. So it all fits together. It's really amazing. I mean, they've never had this level of imaging on a thing like this. So it's pretty exciting to follow along. And I mean, there's already 5,000 images on the NASA website, and it's day 4. So lots of stuff coming in the next days and weeks. So keep in touch with Perseverance for sure. Okay, let's move on. We like to do a little bit of, what's up in the sky. It's not always just cool space stuff.
Hey, Scott, sorry, could I interrupt?
Yeah, absolutely.
Can we just take a couple of quick Mars questions here before we move on?
Oh, yeah, sure. Absolutely. I imagine there's a few.
There's quite a few. I'll try to answer a few others in the chat, but I think, so much focus has been on Perseverance, but there are other successful missions that are going on. Somebody's asking about Alamal, which is the Emirates mission. Quick updates on those for everybody out there?
Yeah. Sure. It's interesting. I went to both of those websites today, and neither the United Arab Emirates mission nor the Chinese mission have put out any more pictures since that first one from the time that they landed. Now, the Chinese space program has always been very secretive, and they release things, not sort of live real time. They put out, a bunch of stuff when they're ready to. So that's not too unexpected. The United Arab Emirates, though, they were really excited. They don't seem to have any indications that there are problems, but they haven't released any other images. So we'll have to see what happens there. I'm a little concerned. The Al Amal, it is their first spacecraft, and so only about 50% of the spacecraft that have gone to Mars have been successful, and like they nailed it on their first try. So I'm hoping that good luck continues and they haven't run into problems. But yeah, alas, no more images have come back.
Okay. And just a quick question. I know we covered this last week when we were talking about, communicating with our rovers, but someone is asking about the length of time it takes for messages and information to go back and forth between our two worlds.
Right. Yeah. The delay time right now is a little bit more than 7 minutes one way. So if you send a command to the rover, it takes 7 minutes to get there, and then it can do that thing and then send a message back that'll take 7 minutes to get to you saying, I did it. So that's why the rover is pretty much what we call autonomous. It has to be able to drive around and make decisions pretty much on its own, because by the time a human from Earth could make a decision and get the information there, the rover would have, crashed into the rock or driven off the cliff or whatever the problem was. So it is a long, long delay, and makes it pretty challenging.
Yeah. Okay. Thanks, Scott.
Okay. Yeah, no problem. Wow. We've got, wow, there are so many things in the chat here. It's kind of amazing. I love it. I love when there are so many questions. If you've been with us since the beginning of the show, you know that we've been basically showing the sky as we would see it at 7 o'clock, because that's when the show starts. And it's sort of like this is what you would see if you would go outside right now. Well, here's the sky at 7 o'clock right now, today, and you notice that it's not even fully dark yet. We're getting to the point where the days have gotten longer, sun is setting later, and we're going to probably have to switch to 8 o'clock for the next show. I can still squeak through with a 7 o'clock view this time, but we'll have to do that as the seasons grow. And yes, yay summer, Lucy, I agree. It is cloudy outside, of course, so we don't really have a good view of the sky either way. But if we could, and remember, when we show the sky, it's good for basically this whole week. And you can find our star charts up on the Manitoba Museum website. The Dome at Home website has the star charts for this week for all the different directions, north, south, east, and west, and right overhead. And that way, whatever way your observing site faces, your backyard, your balcony, in your apartment, your window, or whatever, there's a star map that will show you what you can see in the sky this week. Off in the west, we have still the square of Pegasus. That's about the only thing that's really visible off in the western part of the sky at this time. All the other stars, the other constellations, a lot of them are really faint, so they're not really the big things to see. Off in the south, that's where the action is. It's winter time. We have all the bright winter stars. We'll get into those in a little bit. Very high in the southwest, we still have the planet Mars. You can see it in the sky, the one with robots around it. There it is. Now, we're not looking at it with telescopes right now because it's actually on the far side of the sun. It's about 220 million kilometers away. So even in a telescope, it appears really, really small right now. It was great 6 months ago when it was much closer to the Earth. But anyway, you can still see it in the sky. And rising in the east, we're coming up. We have some of the fall constellations, or pardon me, the spring constellations, like Leo the Lion. And we'll be talking about some of those coming up. We also have the moon. Now the moon, here we'll zoom in a bit so it looks a little bit more like what you would expect. The moon is almost full. And we'll be talking about the full moon and supermoons and all of those things towards the end of the show. But the moon really does interfere with your view of the stars. Wherever the moon happens to be, I wouldn't look in that direction for stars unless you don't really have a choice, because it is tough. It's just really, really bright and makes it hard to see the other stars. Let's move back to the south here, though, because I do want to get us ready for our Connect the Dots segment. Every week we feature a new constellation, or in this case, we're featuring a pair of constellations, and they're ones that you can see in the sky and go out and find yourself. This week, we are featuring Canis Major and Canis Minor. Those of you that are dog people, these ones are for you. These are the pictures that are imagined to be up there. They do not look like that at all, like not even close. Let's take a look at the sky. Here we have, you know, the sky that you're somewhat familiar with. We've got Orion over here. We've talked about Orion many times. He's got the 3 stars across his middle, the belt of Orion, which is a very distinctive thing in the sky. The belt of Orion kind of points down and to the left to a fairly bright star over here. That star is called Sirius, and it is the brightest star in the nighttime sky. So it really, really stands out. It's also, because it's down lower below Orion, it's usually not that high above the horizon. And so it's often flashing different colors, red and green and blue. It can be really, really beautiful. Sirius is part of the constellation of Canis Major, which means the big dog. And so the story is that Canis Major is one of Orion the Hunter's 2 hunting dogs. And with this set of lines here, yeah, okay, it kind of looks like maybe the Sirius is right at the dog's heart, and then there's some faint stars for his head and a body and some legs. Okay, maybe. I still don't think it looks all that much like a dog, but I'll give you that. It's usually very low in the sky, but Sirius really pops out. Now, Sirius is the brightest star in the sky, not because it's a really big star. It's because it was close to us. Sirius is actually a very close star. It's only about 8 light years away. If you remember from previous shows, a light year is the distance that light travels in 1 year. It's about 9.5 trillion kilometers. So 8 times 9.5 trillion. That's basically what Sirius is. So here's a comparison of how big Sirius is compared to our sun. You notice that it's labeled Sirius A. That's because Sirius, like many stars in the sky that we've seen, is a double star. It's got the one big bright star, and then it's got a tiny little white dwarf companion. We've talked a little bit about white dwarfs in the past. White dwarfs are basically what happens to stars like the sun when they run out of fuel and they swell up to become a red giant, and then they shrink down, and all that's left is this tiny white dwarf star. Now, it's so small that it really isn't easily noticeable. It's only about the size of the planet Earth. So Sirius B, the white dwarf, is only about the size of our planet, which for a star is really, really, really small. So white dwarfs really do live up to their name. Because Sirius is so close to us, we can actually see its companion in a telescope. And so if we get some chances to do some telescope viewing over the next little while, we'll try and catch Sirius B, because it is one of the only white dwarfs that you can actually see, because they're so faint that if they're far away from you, we don't see them. So we're just lucky that it's close to us. Okay, so we've got Orion, we've got Canis Major. What about the small dog, Canis Minor? Well, the way that we find the small dog, we've got our friend Betelgeuse up here, this red star in Orion. We've talked about Betelgeuse many times. I've only said it twice. I'm not going to say it the third time. Sirius down over here. If you take Sirius and that other star whose name I'm not going to say, and you make a triangle, there's actually a third star that makes like a perfect triangle with the 3 of them. And that star is called Procyon. And Procyon is part of Canis Minor, the little dog. And here's the red line diagram of all of the stars in Canis Minor. You see it? It's this star and that star. How do you get a constellation out of 2 stars? I mean, come on, really. There was an animated show where they went to the planetarium and we're talking about the constellations, and it was something like, oh yes, and these 2 stars represent the Crusades, and it's this huge incredible picture, but it's 2 stars. Remember, we said not all constellations are named after what they look like. Sometimes they're named after things in honor of things. Sometimes they're named because the story said Orion had 2 hunting dogs and we could only find stars that looked like one, so we're just going to fake this other one. Maybe it's a wiener dog. It's just like a really long, maybe it's a hot dog. You can think of it however you want. Now, Procyon is also a close star to us. That's why it's bright. And interestingly, coincidentally, it's also a double star, and it also has a white dwarf companion going around it. So there's a lot of similarities between Sirius and Procyon. It's just a total fluke that two star systems that are very similar happen to be close to us and in the same part of the sky. So that's kind of an interesting fact there. Do we have any questions about any of the constellations or things like that, Mike, while I'm getting ready for the next segment? Or
well, actually, one that's a really good point. Someone kept asking about how close are these objects? You keep saying, and I know it's a habit that you and I both have when we do planetarium presentations. We talk about, these stars are close to us, but I think we need to perhaps provide a bit of context to how close they actually are.
Yeah, that's a really good point. The distances, and we did do one where we did the scale of the solar system, and we talked about sizes and distances there. All the planets going around our sun, they're all our solar system. All of the stars are farther than that. So all the stars are farther away than Pluto and Neptune and all those things. Much, much farther, hundreds, thousands of times farther away. The closest star to Earth is about a little over 4 light years away. And so Sirius is 8 light years away. So it's twice as far away as the closest star. Procyon is, I think it's 12 light years away. So it's 3 times as far away. Most of the stars, say in Orion, the red, okay, I'll say it, Betelgeuse, said it the third time. Betelgeuse is about 500 light years away. And many of these stars are hundreds or at least dozens of light years away. So definitely very, very far. Even the close ones are very, very far away from us. And that's why they only look like little dots. Great questions.
Yeah, it is a great question. And one more, just because I'm trying to look up the answer myself, because I'm not aware of it, so I don't know if you are either. Someone's asking if there is a system of objects or planets going around Sirius.
That's a great question too. There is not a planet or planetary system that we're aware of going around it. And it's likely that we would have found them if they were there, because basically when you're looking for planets, you're looking for the gravitational pull of planets on the star and moving the star. And that's easier to see for closer stars. So basically planets are easier to find around closer stars. So with Sirius being so close, I'm pretty sure we would have found any large planets. I mean, maybe there's an asteroid belt, or maybe there's small planets or whatever, but I don't think there's likely to be anything big there. And the same with Procyon. Let's see.
Yeah. I think that's it for now.
Okay, great. Yeah. And remember, if we don't get to all the questions, because sometimes they're questions that are sort of on a tangent or a different topic, you can always zap us at space@manitobamuseum.ca, or you can, follow the Manitoba Museum on Facebook or YouTube and drop us comments there. And that is always a way to get a hold of us. Okay, let us move on here. Before we move to the moon, I actually, I did want to talk about something that normally I do at the front end of the show, and I didn't today. We almost always have what we call the Helen Sawyer Hogg moment. Helen Sawyer Hogg, one of my personal heroes, and she was one of the astronomers at University of Toronto, a great popularizer of astronomy, and a great role model for women in the sciences and engineering in the early days. And just a wonderful person. And she's the one that came up with "The stars belong to everyone," which is kind of our slogan here at Dome at Home. I wanted to talk about another famous woman in the United States in this particular case, Mary Jackson. If you've seen the movie Hidden Figures, Mary Jackson and a number of other women were what they called computers, people that would do math to do calculations, because there literally weren't proper computers back in the early days of the space program. And so these computers, these women, would work away at the math, and they didn't really get, the credit, or they weren't the astronauts, they weren't the mission control people, Houston, we have a problem, or any of that kind of stuff. And their story is just now starting to come out. Hidden Figures is a beautiful movie about the early days of space. It's fantastic. Check it out if you can. Mary Jackson is being honored tomorrow because they are renaming the Washington headquarters of NASA, the main headquarters of NASA in the United States, after her, in honor of her contributions. So that's really cool that they're finally giving credit where credit is due, because literally without these women computers, no one would have gone to the moon. No one would have gone anywhere, because the math had to get done. So great story. And that there's a press conference tomorrow morning, I think, where they're going to be making that announcement. But we got a little preview of that here this evening. Okay, now let's move on to the moon. We did talk about the moon, being nearly full. People often say, oh, is it full moon tonight? Is it full moon tomorrow? It kind of looks full for several days in a row, because the appearance doesn't change really that quickly from night to night, especially around the full moon. And so that's something that you'll sometimes hear, oh, it's always crazy when there's a full moon. I work in a hospital, or I'm a police officer, or I work wherever, and there's persistent stories that there are more accidents or more whatever kind of events during a full moon. But here's the problem. The full moon looks full for like about 5 days out of the month. So it's pretty likely that it's going to be near full moon whenever something happens. It's one of those things where we remember those kinds of connections, and then we forget the times that it doesn't fit in. There isn't any credible scientific evidence so far showing that things are more crazy during the full moon. However, there is a little bit of hype around full moons, because whenever there's a full moon, people are always asking, is it a supermoon? Is it a supermoon? Well, what's a supermoon? The supermoon is, well, as the moon goes around the Earth, it doesn't go around in a perfect circle. It goes around in a slight oval. And so what that means is that sometimes the moon's a little closer to us and looks bigger. Sometimes it's a little farther from us and looks smaller. And when I say a little, I mean a little. Here, let me get rid of that picture and bring up that picture. One of those two pictures was a supermoon, and one of them wasn't. Could you tell the difference? Not a whole lot of difference. Now, sometimes they'll put the two beside each other, and there's a noticeable difference if you can compare them side by side, because one's about 14% bigger than the other. But usually you can't do that in real life. So you look at the full moon and it looks super. Don't let someone else tell you when the moon is super. The moon is always super. Anytime you can see the moon, and I see someone has just say they can see the moon through the clouds right now. The moon is always super. It's always worth observing, and it's always different. It's the only thing in the solar system that we can actually see details on with just our eye. Everything else is so far away, just looks like a little dot, and you need a telescope. The moon, you don't need any of that. Brooke, yeah, we'll put that on a t-shirt. That's a good idea, actually. There's a new fundraiser for the museum. I like it. The moon is always super. So at full moon, here's the thing. When it's full moon, we can't see a lot of the details that we normally have been seeing over the last few weeks, where the moon's shadow is creeping along there and sort of showing all of the mountains and the valleys and the craters and things like that. When it's full moon, all the shadows are gone, and basically everything just looks sort of washed out. But it's a perfect time to look for where all the Apollo moon missions landed. You can see basically the whole surface of the moon, and you can see where Apollo 11 landed, right down here in this gray area, which is called the Sea of Tranquility. Up here, the Sea of Serenity, where Apollo 17 was right on the edge of that, and so on. So it's a great time to look for that, and to look for the gray areas in general. These are called the Maria, or the seas. They used to think those were oceans because they were kind of flat, and they thought that the white stuff was all like the land and mountains and stuff like that. It's not, obviously. We know that there's no water there, there's no air there. It's all just rock. And some of these gray areas, you can see this one, for example, is nice and round. That was a giant crater where the crater was so big, it was so deep, it went down into the core of the moon, which was still molten. And the lava came out and filled up the crater and made it nice and flat. So this is basically a crater that is filled in with lava. This one too, and this one over here. And actually some of them, you can sort of see the outlines of them, but obviously they overlap and they have other craters on top of them and so on. So there's all sorts of things that you can see at this time. And some people will put these gray areas together, and humans like to see faces and things. So they say that, okay, here's an eye over here, and here's an eye down here. Here's another eye over here. And then this is the nose. And then this is sort of an open mouth. And that's the man in the moon. Other people see it differently. I've always actually seen this one here as an eye, and this one here as an eye. And then the nose is kind of this bright area here. And then this is the person's mouth, and it's like open and yelling or something like that. I don't know what the rest of this stuff is. Some people say it's a rabbit in the moon. That's one of the stories that I think comes from Japan. You've got the rabbit's head here, and then these are the ears coming up here, and then its body sort of goes down this way, and there's the little cottontail. You can call it whatever you want. Humans really like to see faces and things. But the moon, it's a great thing to look at this time of the year, or at this time of its phase, pardon me. I do want to point out one more thing, because this is also a perfect time for you to be able to see one of the craters in the moon. Most of the craters are too small to be able to see them individually unless you have binoculars. But there's one right down here, right in this area here, that becomes visible. Not the crater itself so much, but surrounding the crater are a whole bunch of these white lines that are sort of sprayed all over the place. When the rock came in and made this crater, there was a big splash. And all of that fresh white soil got splashed all over the moon into these rays. That crater is called Tycho, and it's 85 kilometers across. So imagine a hole that's 85 kilometers across, 5,000 meters deep almost. That's basically as tall as some of the middle-sized Rocky Mountains. That's how deep the crater is. Serious damage. It's a beautiful thing to see on the moon, though. It really is cool. If you get a chance to see it in a telescope, it's fantastic. We'll try and get to that. Here's a contrasty shot here that really shows the crater and those rays sort of shooting out in all directions. Take a look for that over the next few nights, because spotting it can be a little bit of a challenge, especially if the moon is really, really bright. One trick that I use sometimes is I take a pair of sunglasses and I put those on, and it reduces the contrast and the glare for the moon, and you actually get a better view. So that's something you can try. If you've got binoculars, go for it. And for those of you that are keeping your astronomy logbook, I suggest you take a glass and make a big circle, trace it with your pencil or whatever, and then draw what you see on the moon. Draw the dark areas, draw the phases, draw all sorts of things, because that'll really help train your observing eye, and it'll give you a permanent record of your observations as well. Okay, Mike, do we have moon questions here? It looks like a bunch of stuff is shooting by.
Yeah, we do. And let's, there's a couple that sort of go together on Zoom here. Brooke and Glenn are asking, how come the moon doesn't rotate or spin on its axis? And Glenn asked, does the moon spin, and can we see the other side? So I know those questions are related, so let's tie it all in. It's a great set of questions.
Sure. So the moon does rotate, but it rotates almost exactly as fast as it goes around the Earth. So essentially, it's going around the Earth in a circle and turning to always keep its face pointed towards us. So no, we don't ever see the far side of the moon. Now, it turns out that that's not 100% accurate, because remember I mentioned the moon's orbit is slightly oval shaped. That means the moon goes a little faster and a little slower, as well as getting closer and farther. And so sometimes the moon sort of wiggles to one side or a little bit. So you can see just a little bit around one side of the moon or another side of the moon for a few days. So we can see just slightly more than half of the moon in total, but you have to sort of watch it for a long time. I'll bring a graphic up next time around if you want to join us next time to talk about that, because it's something that's easily shown with some graphics, but I don't have that prepared right now. Do we have other questions there, Mike, before I move on to the...
Yeah, another question from Joy here on Zoom, and I apologize. I was half listening, but I'm answering questions on Facebook too. So I apologize if you sort of covered this. But when you were talking about the craters, Tycho especially, Joy was asking, why does the dust splash in a line? So it does look like they're almost straight lines radiating out from that crater. Is there an explanation for that?
Yeah, there's a couple. There's no air on the moon, and so when something gets kicked off the lunar surface, it doesn't get slowed down, or like dust doesn't sort of get pushed around into a cloud or things like that. If you smack the dust would go basically in a pretty much a straight line. And so when this rock came in and it hit the ground, it must have basically pushed there is an area where it sort of went in all directions, right around in this area here. But then beyond that, there's some areas where those lines go quite far. It may be that those are from lighter materials, so they could fly farther. Maybe the meteorite itself was not made of the same stuff all the way through. Maybe it was heavier or lighter in some areas, and that could have affected the pattern. An interesting way to play around with this, though, is to get yourself a pan of, like a pie pan or something like that. Put a bunch of flour in it, just ordinary baking flour. If you're living at a house where your parents are, talk to them first before doing it, if you're under 18, because this can get a little messy. And then, so you got your pan of flour, take some cocoa and sprinkle just a very thin layer of cocoa on the top. That represents sort of the dark surface of the moon. And then drop stuff into the pan. Drop marbles or rocks or whatever, and they will make splashes very similar to Tycho. And because the white flour is underneath the darker cocoa, you get this effect of the white sort of splashing over on top, and you can make all sorts of things. Maybe if coming in at an angle, you might get a different kind of effect. So there's all sorts of ways you can sort of play around with this as well.
And one last quick question, if you don't mind. A bunch of people asking, is it true the moon is moving away from planet Earth, and will it ever escape from Earth and Earth's gravity?
Yeah, so the thing that we have to remember is that the solar system lives on a timescale of billions of years, and you and I don't. In fact, humans have only really been watching the sky in detail for a few thousand years, really, maybe 10,000 years. We'll be generous. That's like nothing in terms of the scale of the solar system. And so over those longer time scales, things were not the same. As gravity interplays between the sun, the moon, the earth, the other planets, there's all sorts of changes that happen. For example, Jupiter used to be as close to the sun as Mars was for a brief period of time. That's a completely different solar system to what we would be used to. But it only happened for a little while, and then it migrated back out into its current position. Similarly, the moon used to be closer, and it has been slowly moving away for a variety of reasons in terms of basically conservation of angular momentum for the physicists out there. It won't actually keep going out indefinitely, though. It will reach a point where basically it gets to a spot where it is what we call tidally locked. It'll be always in the same spot over the Earth, and it will go around the Earth, and the Earth will actually slow down its rotation enough so that it will always have one face pointing towards the moon. So you'll basically have this Earth and moon staring at each other as they go around each other, sort of always pointed in the same direction. So there, at that point, you wouldn't see the moon rise. It would just stay in that one spot in your sky. And if you wanted to, if you lived on the side of the earth where you couldn't see the moon, you'd literally have to travel to be able to see it. Now we're talking millions, billions of years. So it's not the kind of thing that you have to worry about right now. But yeah, all of those really long-term things completely change the solar system compared to what we sort of think we know. We think everything is just stable and this is the way it is. Not at all. Okay. My friend Rowan asked me to talk a little bit, because we were talking about the moon. She asked me to talk a little bit about tides. And this kind of relates to what we were talking about with the moon moving away and stuff like that. So the moon has many effects on the earth. The main one is gravity. Everything, of course, has gravity. The earth has gravity. It keeps us down on the ground. The moon has gravity, not as much as the earth. If you ever saw any of the Apollo astronaut footage, that it's about 1/6 of the gravity. So they only weighed about 1/6 of what they would weigh on Earth. So they could, jump really high and do all sorts of things like that. The golf shot that they shot a couple of golf balls, and they would just went for miles, basically, because you could hit really, really far. The gravity of the moon, though, is still strong enough to reach all the way down here to the Earth, and it pulls on the Earth. So it pulls the Earth a little bit closer to it, and the Earth pulls the moon a little bit closer to it. The Earth itself is made of rock, though, so it's not really going to stretch around. But the outside of the Earth, there's a lot of water on it, and the water can move. So when the gravity pulls on the water, it actually pulls it up towards the moon. And so the ocean gets deeper there. And because of the way the water sort of flows around, the same thing on the opposite side, the water gets deeper there. And over here, the water gets shallower. Now, this is a super exaggerated kind of thing. The ocean is kilometers deep. And in most places, the tide only changes by, a couple of feet. It doesn't really change and turn egg-shaped like this. But this is just to show that the ocean gets pulled towards the moon, and that makes high tide. And then remember, we're on the Earth here. The Earth is rotating. So if you were here at, say, 1 o'clock and you had what is high tide, well, at 2 o'clock, you would be over here. And then at 3 o'clock, you'd be over here, 4 o'clock, 5 o'clock, 6 o'clock. Now you're in low tide. And so as you rotate around on the Earth, you go from a place where the moon's gravity is pulling on the ocean and a place where it's not pulling on it, essentially. That's super simplified because there are many other things in play. The sun has gravity too, and the sun has an effect. And as we know, the moon and the Earth and the sun are all, in motion. When they line up, sometimes those gravity effects add together. Sometimes they cancel out. Depends on the configuration of things. So if you ever look at what the times are of the tides, for those of you that live near an ocean, it can get fairly complicated to forecast. And it changes almost every day in terms of the time, in terms of how much the tide is going to go in or out, but it's all due to the moon and its gravity. So I hope that helps with your question there, Rowan. Keep being curious, and thanks a lot for sending in the pictures and stuff like that. It was great to see. Okay, let's see. How are we for time? We're almost out of time here. Can't believe this show has just flown through. Mike, do you have, oh, there's like 99 new messages in the chat. Do you have anything you want to bring up right now?
No, I mean, there are lots of great questions. Unfortunately, we're just not going to be able to get to them all. I think people are very interested in the whole concept of tides. I think that's really great. And although Brooke does ask, does your head ever hurt thinking about all this? I think that's a great question.
Oh yeah, you know what? All the time. You kind of, as an astronomer, have to get used to having your mind blown, because if you actually sat and thought about how big things are, or how far away things are, or how many stars there are, your head just explodes. So astronomers hide their wonder in large numbers, and they invent these units so that they don't have to make the numbers too large. They say, oh yeah, that star is 8 light years away. 8, I can figure out 8, I can comprehend that. When in fact, it's actually 8 times 9.6 trillion kilometers. So it's 720 trillion kilometers. So 720,000,000,000,000,000,000,000 kilometers. It really is amazing that we can see and understand anything of the universe from our backyards like this. So I'm pretty impressed that that works. Now I realized that there was one thing I wanted to. There we go. We've been getting a lot of northern lights in the last little while, which has been fantastic. There are huge interest in northern lights. There's a Facebook group for Manitoba called Manitoba Aurora and Astronomy that has got about 10,000 members, and the pictures that are showing up there, and the people are helping each other, saying, oh, the northern lights are visible right now from here or whatever, is really, really a great community. But a lot of people are asking, how do I know when to go? How do I know where to go? What do I do when I get there? Like, how do I take pictures? So the museum has decided sort of last minute, we're going to be running a workshop called Chasing the Northern Lights. And so it's on Tuesday, March the 2nd, because we're thinking that there's going to be some more northern lights coming in early March, and we wanted to get it in before then. So this is a paid workshop. So it's not a freebie, unfortunately, but it's fairly affordable, and it's per device. So if you've got 8 friends that are all watching on the one laptop, that's totally good. There's another one on March 13th. If you're more of a Saturday person, we can do a Saturday afternoon one as well. But that's available, and registration is already up for that. So you can check that out. And yeah, that's
well, you can't have 8 friends around one device, Scott, because that's against our health regulations. But 8 family members from the same household can definitely be around the same device.
Thank you for that, Mike. That's a very good point. I just saw also something here in the chat. The show Dome at Home will be at 7 o'clock every week. However, I won't be able to show you what the sky looks like at 7 o'clock because it would still be daytime. So we'll be starting to make our star maps that we make for you to be for 8 o'clock, but the show will start at 7 o'clock. I know when I said it at the beginning of the show, it was a little bit confusing there, but basically this show will always run at 7 o'clock on Thursdays through the end of March. And we're already thinking ahead to what we're going to do after that in terms of how the show will evolve and things like that. That's when the Safe at Home program ends from the province, which is what's supporting this. But we've built such a great group of folks here, a great community, and we want to keep going. So we're going to be doing some things after that as well. If you want to help us decide what that next step will be, fill out the survey that we put in the chat for every show. We'd love to know, where you're watching from, how many people are with you. We'd love to know what you'd like to see. You can always drop us a line, like I say, either through email or through the, here we go, or through Facebook or YouTube. We're always happy to hear from folks. Remember to get us your Mars videos. The videos of the Mars landers that you've been making with the egg pilot inside, for those of you that are doing that. And you can always download all of our star maps and the activities for today as well. We were going to be doing a planisphere activity that we didn't have time to work through today because of all the great questions and all the great Mars stuff. That is available on our website, and I will it includes instructions. Most people will be able to figure it out because it's just cutting out a couple pieces of paper and sticking them together. But that gives you a star map that you can adjust for different times of the night to counteract the motion of our planet. So you can always know where the stars are going to be. That brings us to a close. It's almost 8 o'clock. And unfortunately, we can't just go outside and look at the stars tonight because it is kind of cloudy, but keep your eyes open. The clouds will clear. We will have nice warm skies coming, I hope. If not, dress up nice and warm, and you can still weather the cold. The Northern Lights event, I just saw a question here, Charity. You can visit the Manitoba Museum's website. Mike will put the link into the chat here, and you can click on it, and that'll get you to the registration page for that. There we go. There's the link. So you can click on that, and that'll get you to our website. Thanks again, everyone, for joining us at Dome at Home. Next week, we'll be back, and we will be taking a look at, let's see what we have on for next week. We've got Planet Mars is passing the Seven Sisters. We're going to talk a little bit about daylight savings time, what that's all about, and there's some strong opinions there. We're going to be finding Cancer the Crab, our zodiac constellation, and we'll look back on the last 10 years of human spaceflight, because it's been 10 years since the last space shuttle landed, as the space shuttle program has ended. At that point, we thought, ooh, what's next? Well, obviously, people haven't been resting on their laurels. There's been lots of great stuff going on, so we'll be talking about that. Thanks again, everyone. Have a wonderful week if I don't see you before then, and I hope you get a chance to get out under the stars. Go and enjoy your stars and clear skies. Have a wonderful evening.